Hi, thanks for joining. Today I'd like to discuss the target pin. This is something that we often use and sometimes may not quite know if we're using it in the right way and where this came from. So hopefully this will help clear things up. The target pin is something that we use on send signal actions, and we typically add that as a means to tell the reader where this signal is intended to go. So if you look at this activity diagram, what you see is we have an accept event action, there's a few call behavior actions, and then at the end here we have this send signal action where we're sending a signal that is called bit status transmitted. Quickly looking at this architecture, what you see is we have a system context, our system of interest is here, we have an external system and a user. So what I'd like to do is add a little bit more information to denote where this signal is intended to be sent, whether it's being sent to this external system or whether it's being sent to this user. So to do that, we can add a target input pin. So you click on the send signal action, and if you look, you have an input pin here. Select that, and then you have two options, in a new argument pin or a new target pin. Now, currently we already have one argument, and that's the bit status. So an argument is basically an attribute, and we can actually feed real data into that signal to be packaged up and sent wherever we'd like it to go. So in this case, we know what we're sending with this signal, but we don't exactly convey yet where this is going. So we'll add this new target pin. When we do that, it's called target. So what you should do at that point is type the target pin by the destination for where you'd like this signal to be sent. So in this case, let's say we'd just like this to be sent to the user. So we can search for user and select that. And notice it's not displaying until we say show type. So we're now saying that we'd like to send this signal to the user. And that's great. It's good for the reader to understand where you're intending to send this. However, if you were to go to simulate this, what you'd find is you would cause your simulation to fail because the default multiplicity on this pin is set to 1. Or if you notice, it's currently unspecified, which means when this executes, it will default to having a lower bound and an upper bound multiplicity of 1, meaning it requires an input to this target pin in order to enable the send signal action. So this send signal action will never become enabled because this will require an actual input of an object flow in order to enable this send signal action. So one thing you can do is simply tell it that you don't require an input. So you could use a multiplicity of 0 or 0 to 1, 0 to many, or an asterisk to say that as it's essentially the same thing as 0 to many. So a lot of times I'll add that in to enable the use of simulation without actually causing this to fail. So that may be great, and it actually works in the simulation, but then you start asking yourself, well, why do we need to do that? What was ever intended to be input into this? And one thing you can actually do if you prefer not to have that multiplicity set to an asterisk is actually feed it an object. So you can do that through the use of your objects that you have in the drop-down menu next where it says call behavior action. If you go to any action, you have a list of a lot of UML actions. And one that will enable this to work would be to simply read self, and it'll actually read the context of who is sending this and feed that to the target, but that doesn't really make a whole lot of sense. So you could also grab the object of or create the object of the target by using a create object action. So let's say we use a create object action, and then we can drag in the object that we would actually like this to be sent to, which is the user in this case. So we'll drag in the user. Now that user will be instantiated during this simulation. We can feed that to the target input pin. And then we can get rid of this multiplicity that says 0 to many, because now we actually do have something being fed to that target pin. So we'll go back in here and say simply unspecified, which will default to 1. And then this should execute when we send this signal. However, right now we don't have anything set up to receive this signal. So we could set up something to where we would actually receive that signal and verify that it's being sent. But before we do that, I'd like to delve briefly into the UML specification, because that is actually where you'll find a little bit of information on this target pin and where it came from. If you delve into the SysML specification, you'll not find anything on the target pin, because this is actually a carryover from the UML spec. So let's look at that UML specification briefly and see what it has to say about the target input pin. And if you look here, around page 452, I believe, 452, it gets into send signal actions in the UML specification. It says there are 3 kinds of send signal actions or send actions. And it says a send signal action is an invocation action that creates a signal instance and transmits the instance to the object given on its target input pin. So that is in line with what we just did. In the activity diagram, we selected the object that we would like this to be sent to. And it says a send signal action must have argument pins corresponding to each of the owned and inherited properties of the signal being sent, which we also have as the argument pin, with the same type, ordering, and multiplicity as the corresponding attribute, which we have. The values of each property of the transmitted signal instance are taken from the argument input pin corresponding to the property. The handling of the signal instance by the target object is described under behavioral features and methods in the subclause. So that gives us some indication that what we're trying to do with that target input pin is actually designate where that will go. The one downfall of Cameo Simulation Toolkit is that if you were to designate this as a user being the block or the class or the object that should be receiving this in runtime, what will happen is it will not actually be sent to that user or to that system that you would like it to get to. So if you're trying to do simulations and actually have a signal sent to a specific instance of a class or a part property, the better method for doing this, and you can do both of these, a blended version, would be to not use this input pin, but set this multiplicity to 0 to many so that it does not require an actual object flow as an input, and then designate the port for which you would like to send this signal, because that will actually carry your signal through a port via a connector and then have it arrive at the part property that you would like it to be sent to. So we've said that we'd like this to go to the user. We understand that Cameo Simulation Toolkit has a limitation where it will not actually send it to the user. So we get around this by saying to the reader, you'd like to send this to the user, but then how do we actually get it to send to the user? We can do that by designating the port. So in order to have a port to send this to, we first need to create a port. So keep in mind, right now, this initialize activity is part of this use case. That means the activity is being executed by the system of interest. So the system of interest needs to have a port that connects to one of these external systems or external users. So what we can do is add a port here, and we'll call this user interface. and that is a proxy port. And typically we will type proxy ports with interface blocks, but in this case we actually don't need to have that interface block in place. So what I'll do now is create another proxy port that this will connect to. So we'll call this the system interface. And now I'll connect these up in an internal block diagram. So to do that, we'll go one level up in our hierarchy so that we can bring in these part properties, because that's what we will actually be sending these signals to and from, is the usages of these definitions or the usages of the blocks, not the actual blocks themselves. So we'll right click in the system context block, create an internal block diagram, and then we'll take a look at connecting these together. So we'd tell Cameo, yes, we'd like to pull in all of these part properties here, and we'll go ahead and check the box for these ports as well. So user interface and system interface, and then we'll simply connect these proxy ports together with a connector. And that connector will allow us to send information from one thing to the next. So we don't actually need this in this diagram. And then what you see is we have proxy port connecting the system of interest to the user. And that's a logical interface that you could use then to later define some of the ICDs where you'll actually show all of the types of signals or all the type of data that you would like to send to that user. So in order to designate that port, what you do is go back to your send signal action, go to the specification, and then look for on port. So if we change this to simply expert mode, you'll see a little bit narrower scope here, and you can see on port. And you always want to designate the port that this is leaving. So as I mentioned, this activity is being executed by the system of interest, so we need to designate a port of the system of interest. So let's go to the system of interest and find the user interface. Say OK. Now I've designated a port. And then notice our send signal action now says the bit status will be transmitted via user interface. And that's the port that we'll be sending this via. So what I'll do now is pull in the IDD of that system of interest so that we can actually watch this being sent. So let's look at the system context. And then we'll go ahead and run a simulation with context, meaning we'll have access to the value properties of the executing context or the block that's executing this. And let's see if anything happens. I don't think it will happen because we're actually only executing at the level of the system of interest currently. So what we can do is execute the system context block, which will instantiate all of its part properties. So system context, run the simulation from there, and notice we have all of our part properties instantiated. Then we can go back and still look at the other diagrams. And when we run the simulation, what we should see is that this initialize activity should begin. And then notice we now have enabled this turn on transmitted accept event action. And then we can send that signal through here and watch this be sent. And what you saw is that signal was sent directly to that user or the part property typed by the user block, which is exactly what we wanted. And then that is re-enabled because there's only one flow happening in this activity. If there are multiple flows in this activity, we would want to have an initial node with a fork that would show some loops there. Otherwise, this would execute and then wait for the other concurrent flow to execute. So that's something to keep in mind as well when you're running concurrent flows, is whether or not you need to have an input control flow to that accept event action. So looking at this again, we'll slow this down. And then notice we're sending that signal to via that user interface, and it's sending that actual signal there. So what you could then do is accept that signal as an event with a user behavior. And we'll do that really quickly just to see what that would look like. So inside of this user block, we'll create an activity diagram that will essentially catch or receive that signal. So we'll create this and do an accept event action. And then before we drag the signal onto this accept event action, it's good to set isOnMarshal to true. That way you can automatically parse your attributes of your signal. So I'll do bit status transmitted. Notice we now have the output pin from that where it will actually output the bit status. And then what we can do now is read that actual status from this signal through an object flow. So one thing you can do is read it. The other approach is to simply set it equal to a value property that has the same type, and that has some caveats to where you may not want to do that in some instances because it actually sets object IDs the same. However, in this case, we'll do this just for the sake of showing that that data has arrived. So what I'll do is add an opaque action within input pin. And we'll call this bit status. And then we'll type this. Notice it has no type. This should have a type because it should be typed by the enumeration that is typing our attribute. And the attribute, or that enumeration, is called bit status kind, that has two enumeration literals, that being whether or not the bit is passed or failed. So what we can do is drag in the enumeration that types that attribute and type this input. And then we'll show both of those just for the sake of showing that they are the same. So we know that they are now the same, which is a requirement for them to be the same. You cannot change types across an object flow. So now that we have bit status entering here, let's say that x equals bit status. Or let's actually change this to be called x typed by bit status kind, and then we'll say that bit status equals that. And bit status will be the name of a value property of the user. So for the sake of simulation, we'll actually add that here, and we'll go back to this and say that there's a value property called bit status. And it'll need to be typed by that enumeration as well. So we can type that enumeration, or type that value property with the enumeration. And let's set a default value for this so that we can see if it actually changes. So we'll go into the specification for the value property. When we go to default value, we'll say that by default it is failed. And what we'll do is try to actually change that to send a passed signal with that signal in the simulation. So going back to this diagram, we will rerun the simulation from the context, and then notice we have a default of bit failed, but I'll change that to bit tasked, and let's see if we can get that to, oh sorry, let's leave that at bit failed. What we'll do is try to adjust that with the signal and have that set to pass. We don't have anything currently that is actually setting that value from the of this signal inside of this call behavior action, which is why that's simply going to set the default value. But what we could do is delve even further into this execute built-in test, create a diagram that will actually output a real value for this. So let's go to an activity diagram. And for the owner of this, we'll select the execute built-in test. Let's see. Select owner. Actually, let's set this owner as the system of interest. Okay. All right. And yes, we'd like to have the output pin of bit status, which is where that value will actually be sent. But now what we can do is do an opaque action that will actually toggle whether or not that is set to pass or fail. So let's go to an initial node, and then we'll do control flow to fork, where we will then fork out to two different opaque actions. Let's take a look at that now. And we'll go. Let's go back to executing from the system context. And then take a look at our other activity here. There it is. All right. And then we'll execute this from here. And then we'll see what's happening here. So currently the user has an activity and their bit status is failed. What we'd like to do is flip that to being bit passed. So to do that, we will send this signal to allow the turn on transmitter to be sent. That will delve into this activity called built-in tests. And let's find that in the containment tree. And I believe that is this activity here. So we can watch this delve into that activity. All right, that should become enabled here in a moment. It is, and then this should prompt us with whether or not we'd like to set that to passed or failed. So let's say passed, and it'll take the passed path. Here's bit passed. And then that pops out there. See a few things being flip-flopped here. And then if we look, we now have user has their value property set to bit passed. So it started as default. It was bit failed, and now we flipped it to bit passed. So that is a way that you can actually send real data and have that target pin come full circle. We started with this conversation about the target pin, and I digressed a bit, but I think that's important to see that a lot of times it is because you'd like to tell the reader where that signal is intended to be received. However, in your simulation, it's usually best to have this to where you're not actually requiring an input on this target pin. Rather, you should use the on port of the send signal action to send that signal. And then what you see here is how you can actually send that signal and receive it on the other side. If you guys have any other questions about this, I'd be happy to answer those. Otherwise, thanks for watching.